Hi, my name is Kailin Tegra da Silva, and I'm going to present to you the paper Design Practice for Sustainability, Development of a Low-Cost Orthosis. The authors are Kailin Tegra, Isabela de Souza Sierra, Dominique Leite Adam, Maria Lúcia Leite Ribeiro Kimoto, José Guilmar Fogiato. Design practice has evolved in terms of scope and approach. Its scope increases as it fits into medical and engineer contexts as a possible problem solver in ways not previously presented to the original developers. By having a role in the user-centered design practice, design stands as an alternative project mediator within related areas, considering the contexts and the functional, aesthetic, social, and symbolic needs of the product's users. In terms of changes in approach to design projects, there is a confluence of the insertion of other areas such as ergonomics, sustainability, and assistive technology into the design process and the natural evolution of the area itself. Assistive technology products are developed to increase the autonomy and functional capacity of people with disabilities and reduced mobility for quality of life improvement and greater social inclusion. The products are traditionally developed handcrafted by skilled professionals, generally with medical training. They normally only consider the functional aspects of the product, lacking solutions that meet all the user's needs, whether they are functional, symbolic, and/or aesthetic. It causes abandoning, discarding, and waste of products and inputs. By using a user-centered design approach, it is possible, for example, to use specific techniques and tools that provide the most appropriate solutions to the global context and the needs of users and the societies in which they are embedded. New technologies such as 3D printers and 3D scanning, when combined with project planning, contributed to the creation of more sustainable products. For example, the additive manufacturing facilitated the production process, spending less material needed to product development. In addition, it is possible to use materials such as PLA, polylactic acid, which is a biodegradable polymer constituted by the fermentation of starch-rich plants, which, when converted into filaments, can be used in 3D printing projects or reuse the materials into filaments for the generation of even more sustainable products. This paper presents the development of an assistive product, a wrist-to-hand orthosis, which encompasses the principles of product development from a user-centered design approach and taking into account the principles of sustainability and new technologies available, mainly low cost. It discusses the possibilities of the use of new technologies as allied to the development of sustainable and ergonomically adequate projects and the aesthetic influence of the product for its acceptance. In addition, it discusses complexity in an interdisciplinary process. From a user-centered approach, the process prioritizes the functional, aesthetic, and symbolic requirements of the product, as well as design requirements that aim at sustainability, low cost, and customization. At first, the problem, the context, and the target audience were identified. Following an experimental phase of the study was started, composed by the generation of alternatives, selection, and prototyping. At this stage, from the pre-established needs, 5 design alternatives were developed for the design of the orthoses. Among them, one was selected as a final alternative to be prototyped. To do this, it was necessary to acquire the anatomy of the wrist, followed by 3D scanning, modeling, 3D printing, and finishing. It is important to emphasize that the experimental study is not linear and that the link between methodological approaches, and productive process depends on calibration and adequacy of theoretical and technological languages. In this way, it is possible to go back to the previous steps in order to verify the best design solutions according to the problem encountered in the production limitations. So, the persona was a 43-year-old woman with a chronic tendinitis in the wrist. Medical recommendation is the immobilization, but she wants to feel included in the society with a wrist hand orthosis that can be used during a social event. In this case, we have a classic case of user looking for an assistive technology product that is inclusive and does not embarrass or humiliate her when used. We use plaster bandages to acquire the wrist hand morphology and the recap software for 3D digitalizing. The mesh treatment and preparation defect repair was performed with a mesh mixer software. A study of design alternatives was conducted and one design was selected. With the wrist mesh repair, the design changes were made using Rhinoceros and SolidWorks. Finally, the file was finalized with the Repeater software, and for this project we used a 0.3 millimeters thick layers of PLA filaments with the low-cost 3D printer Stella. Here you can see the printer working. In left, you can see the problems we had with the printing process. The filaments does not work well. It is essential to identify project and product limitation and also benefits of the integration of design and new technologies plus their contribution to sustainability. The main problems of AT development are waste, obsolescence, high cost, the inadequacy of products that cause abandonment, and early disposal. Consider aesthetic and symbolic sustainability of the product tends to raise the complexity of the development process. Still, we recommend to consider these aspects to ensure the development of a product that satisfies the user in all aspects. Acquisition of the anatomy using a cast bandage proved to be an economically viable process. 3D scanning using recap software did not present miserable technical problems. The 3D modeling presented some technical limitations, organic lines, transition between solid surface softwares, and inexperience of using them. 3D printing failures during the 3D modeling made the process difficult, resulting in unnecessary material expenses. Although this work is an experimental study designed to discuss the articulations between design, sustainability, assistive technology themes, the fundamental problems of process adequacy suffered by the industrial and product manufacturing are present. It means that the solution to these issues needs to be articulated at several levels and later expanded. We acknowledge that this is a complex project because it requires the designers to seek and articulate concepts and technologies. Nevertheless, such solutions contribute to the popularization of 3D technology, which is currently expanding to converge to customizable, sustainable projects, and yet considering the subjective requirements of users. So these are the presentation references. We would like to say special acknowledgements to Laberg, UFPR, Nufer, UTFPR, and PPG Design UFPR. And also CAPES. É isso, obrigada. Thank you.